Good morning, Teacher Robert. Good morning, classmates. This is our report in science, electricity and electromagnets. What is electricity? Electricity is the interaction of electric charges, a physical phenomenon associated with the flow of charged particles. Electricity can run specific cars, light a bulb, cook food, turn the blades of a fan.
Electricity. Visualize a different world where you couldn't turn on a light, a computer, or even use the electric kettle to make your favorite hot chocolate drink. We use electricity constantly in our daily lives. It is one of our most important types of energy and power that we use. Its uses range from small batteries that operate your remote control car to huge motors that power ships and trains. Electricity operates our lights, runs our refrigerators, kitchen appliances, and powers motors. So electricity is very much important to all of us. It takes a lot of work to generate this magical thing called electricity. Let's first learn the most popular way to generate electricity. How to make electricity. We get the electricity by simply changing other forms of energy. For example, we can burn coal or many other fuels which diverts chemical energy into thermal energy or heat energy. Heat energy will cause water to heat sufficiently and move in a tank. Energy of motion is kinetic energy. The kinetic energy in moving water causes a turbine to turn a generator. A generator changes kinetic energy of a spinning wire or coiled wire to electrical energy. The wire is surrounded on both sides by a very strong magnet. On one side, the negative side of the magnet is facing the wire. On the other side, the positive side of the magnet is facing the wire. Electrons within the wire are attracted to the north part of the magnet and will push away from the south part of the magnet. By spinning the wire, it continuously passes by the two opposite charges of magnetism. The electrons within the wire move towards the positive magnet end and away from the negative magnet end. We see uses of this electricity in our homes and schools. Now let's remember the definition of electricity. Electricity is a type of energy that can build up in one place or flow from one place to another place. There are two types of electricity, static and current. Let's study about these one by one. Static electricity. When electricity gathers in one place, it is called static electricity. For example, when you rub your feet on a carpet and then zap something when you touch it, it is static electricity that you have built up on the surface of your skin, discharging onto another object. Lightning is also a powerful example of static electricity. Current electricity. Electricity that moves from one place to another place is known as current electricity. Examples of current electricity are starting a motorbike, turning on a light, watching TV, playing video games, charging a cell phone, and many more. Do you remember whenever you visit the local grocery shop, they use weighing machines to measure the weight? Do you have any idea how electricity is measured? No, it cannot be measured like that. We can measure electricity in a number of ways, but few of them are particularly important. Voltage. The voltage is a type of electrical force that makes electricity run through a wire, and we measure this in volts. The greater the voltage, the more current will tend to flow. Volt is an electrical unit of voltage that is represented by the symbol V. Current. Voltage itself does not go anywhere. What moves through the electrical wire in a circuit is an electrical current. It is a steady flow of electrons that is measured in amperes or amps. Power. Together, voltage and current provides us electrical power. The bigger the voltage and the bigger the current, the more electrical power we have. We measure electrical power in units called watts. Now, we are all impressed with various uses of electricity, but it is dangerous as well. It sounds so scary, and it is. If you remember the safety rules, you can use electricity without getting hurt. Below is some safety rules before using anything related to electricity. Don't plug a lot of stuff into a single extension cord. Always fly your kite away from power lines. Keeping electrical things far away from water. Do not climb a tree near power lines. Always wear unwet slippers before touching any electrical equipment. Stay away from broken or fallen power lines. Always ask your parents' help before touching electrical equipment. I hope now you know much about electricity. Be careful while using electricity and be kind to one another. Thanks for watching. Bye-bye.
Electrical conductors and electrical insulators. The plugs at your home has prongs that are made by metal, while the covering is rubber or plastic. Metals allow electricity to flow freely. Rubber or plastic do not allow electricity to flow through. These materials are called electrical insulators. These are the prongs or metals that allow electricity to flow freely, while this is the rubber or plastic that do not allow electricity to flow through. Again, electrical conductors allow electricity to flow freely, while insulators doesn't. Electrical circuit is a path where electrical charges flow. A simple electrical circuit is composed of an energy source. Changing the number of batteries. Adding a power source in the circuit will make the bulb brighter because of more energy. Lessening the number of batteries from the circuit will make the bulb glow dimly. Changing the diameter and length of the wire. The length of the wire offers resistance that uses up energy. Longer wires will cause the bulb to glow dimly, and shorter wires will cause the bulb to glow brightly. A thicker wire will make the bulb more brightly because energy can flow freely. Goodbye, Teacher Robert. Goodbye, classmates. The next reporter is Gab.
Good morning, Teacher Robert. Good morning, classmates. This is our continuation of the report. Changing the number of loads. Adding bulbs in a series circuit will make the bulbs glow dimly because energy will be distributed among the bulbs. When electricity flows through a wire, a magnetic field is a region where the magnetic force is felt and is usually near a magnet or a material that behaves like a magnet. Electromagnet. The moment electricity is cut off, the magnetic field disappears. Factors affecting the strength of an electromagnet. An electromagnet can be made stronger through the following. A. Increasing the number of coils. The stronger the magnetic field around the wire, the stronger the electromagnet is. B. Increasing the electricity running through the wire, increasing the amount of electricity in the wire. C. Using a bigger wire, it allows more electricity to flow. Applications of electromagnets. Electromagnets have various applications. Even the speaker of your phone and headsets are examples of things that use electromagnets. Did you know Alessandro Volta is an Italian physicist, inventor of the electric battery, born in 1745, studied electrophysiology. He lived to be 82 years old, passed away in 1827. A nature lover, experimented with frogs. Goodbye. Thank you for listening.
To our report.